Um, lesson 5, sorry, unit 2, practice in 5. So we're dilating, okay? So what's really important in dilation is what gets scaled up or down is the distance you are from the center. So it's really important for you to know where the center is, okay? If the center is 0, 0, life is beautiful. Because all you gotta do is multiply the scale factor by the points, the x and y coordinates, and done. If the scale factor is not 0, 0 and ends up being somewhere, I don't know, over here, sorry, let me clear it up. Right, so let's say the center of dilation is here, then you're going to have to start counting and then double that distance that you counted, not double, scale up or scale down. Let me use an example. Hopefully we'll get to some examples where I can clear that up for you. So let's look at the first one. Quadrilateral ABCD, it's dilated. They want to know what was the dilation and what the heck was the scale factor dilation. Oh, and they only gave us B. So remember, if I find out what the scale factor here is, I can apply it to the other points. So let me just tell you point B. Point B, where's the center dilation? The center dilation, the origin is the center dilation. So 0, 0 is the center dilation. All right, so let me write point B for you. So from the center, if I had to walk to point B, I would go 2 to the right. There you go, that's 2 to the right, 2 positive, and I would go 2 up. That's how I would get there. To go B prime and just say, hey, we dilated B, that distance. And now to go to B prime, I'm going to go 1, 1, 2, 3, 4, 4 to the right. And 1, 2, 3, 4. So can you tell me what happened? And let me put the original distance. The original distance went 1, 2, and then 1, 2. 2 up, 2 right, 2 up. So what happened to the distances? Well, we can clearly tell that all these, right, were multiplied by 2. So the scale factor is 2. Now, what I'm going to do is apply that scale factor to all the other points. So let's take point A. Point A was negative 2 comma 3. If I do a scale factor of 2, point A prime is going to be, and let's say multiply this by 2, right? So we're going to multiply that by 2. So negative 2 times 2 is negative 4. 3 times 2 is 6. So negative 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There. That's A prime. Let's do C. Well, C is 1, negative 3. If I multiply those coordinates by 2, I'm going to get 2, negative 6. So C prime is going to be 2 to the right and 6 down. 1, 2, 3, 4, 5, 6. And there's C prime. And then D, change colors. D is at negative 2 comma negative 1. I multiplied those two coordinates by 2, so I'm going to get D prime negative 4, negative 2. So negative 4, 1, 2, 3, 4, 1, 2, right here. So if I connect dots, and you connect the dots here, and please notice the shape. It's the exact same shape, except that the dimensions, everything got doubled, right? So if you think about the distance AB, now A prime, B prime is double that. If you think at the line segment BC compared to B prime, C prime, notice that it's doubled. Okay. Yeah, that's so when it's at the center, it's really not much to do. Let's look at this one. ABC, center is your center of dilation, so let me put a dot there. And scale factor of 2. Okay, you draw the triangle, the dilation of the triangle, and label the triangle DEF. Why would I label it DEF? All right, so let's do this. So, and again, let's do A. So let's find out what A is first of all. A is 1, 2, 3, 4, 4 to the right, and -2 because it's 2 down. A prime. So if I were to do A prime, where would A prime land? Well, I'm going to have to double that distance. So to go, I went 4 right and 2 down. I'm not going to do that. I'm going to go 8 right and -4 down. Why? Because my scale factor is 2. So literally, I just doubled the vertical distance and the horizontal distance. So let's go to A prime. 1, 2, 3, 4, 5, 6, 7, 8, and then 4 down. 1, 2, 3, 4. So here's A prime. B prime. Well, first of all, where's B? B is at -2, comma, -2. You went 2 to the left and 2 down. We're going to double that distance, so it's going to be -4, 4 to the left, and 4 down. 4 to the left, 1, 2, 3, 4, 1, 2, 3, 4. And there we go. There's B prime. C. Where's C right now? It's -2. C is at -2 and 2. So 2 to the left and 2 up. That's what that means. Double that. So we're going to go 4 to the left and 4 up. So 4 to the left, 1, 2, 3, 4, 1, 2, 3, 4. And that's going to be C prime. That's how I would like you to think of dilations. Right, same exact shape. Look at that, beautiful. Right, so, and this one has a couple of examples. So let me show you here. I want you to focus on B to A. So from B to A would be 1, 2, 3, 4, 5, 6. So that line segment B to A was just doubled. B prime to A prime should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. 11, 12. So that was 6. Now it's 12. Let's compare another one. C prime. So B to C is 1, 2, 3, 4. And if you double that, B prime to C prime should be 8. 1, 2, 3, 4, 5, 6, 7, 8. And it is. So we're very good. Let me erase everything. It says use the center again, but the dilation here is a half. Well, half means it's going to be a reduction. So let's go to point A again. Point A was 1, 2, 3, 4, 4 to the right, and then 2 down. If you multiply that by a half, so if you times those 2 points by half, and this guy by half, A prime will be half of 4 is 2, and half of 1 is -1. So 2 to the right, 1 down. There's A prime. B. B was 2 left, so point B again was -2 to the left and -2, 2 down. So if we cut that in half, if you multiply those 2 points times a half, B prime is going to be -1, comma, -1. Right here. C is at -2, 2 left and 2 up. There's your point. Multiply that by a half, and multiply this by half. We're going to get -1, comma 1. So 1 to the left and 1 up. And there's your triangle. But with half, all the dimensions are half the original. Okay. Everything's center dilation with triangle GHI. Where's triangle GHI? It's a dilation triangle DF. Identify the center dilation and scale factor. What are we talking about? Oh, no. So question 6 says GHI was for GHI. Sorry, not that. I gotta actually move this down. Let's see is that what I have? right? So that's what I had before. What was the center of the? So I'm trying to answer question 6. So instead of A prime, B prime, C prime, there I should have. They said they actually told me to label as GHI. So what was the central dilation? The central dilation was the center, right? And 0, 0. And what was the scale factor? The scale factor was a half. That's kind of weird that they asked that question. Anyways, next one. Oh, finally. Triangle ABC has vertices, okay? Triangle A prime, B prime, C prime is the result of dilating the triangle using point 0, point O, negative 5, and 1. So let's first of all plot the triangle. Negative 3 and 3. 1, 2, 3. 1, 2, 3. So that's point A. Point B, negative 2 and 3. Negative 2. What in the world? Why is it? Here's point B. What's point C? Negative 1 and 2. So here is the very silly triangle. And we want to dilate this. Oh, I see. We want to dilate this scale factor of 3. So this little triangle is going to be 3 times as bigger. All the side measurements are going to be 3 times as big. But the center of dilation is not 0, 0. It's negative 5 and 1. So negative 5 is here. Here's my center. So let me change. So here's my center of dilation. This one we're going to have to count. So we'll put C for D for dilation. C, because I already have a C. I'm going to use, I'm just put point O. Okay, so let's start from point O to A. How do I get there? Well, music is annoying. Point O to A. Right? If you were to tell me to walk from point O from A, I would go 1, 2, 2 to the right, and then I would go 2 up. That's how I would get from O to A. Now, scale factor 3 means we're going to multiply these two numbers by 3 times 3 times 3. So now we get 6 and 6. So to get to, so increase that scale factor by 3, I'm going to go 6 to the right. 1, 2, 3, 4, 5, 6, and 6 up. 2, 3, 4, 5, 6. Here's my A prime. B. From O, how do I get to B? Well, I would walk 1, 2, 3 to the right, and then I would go 1, 2, and then I would go 2 up. And again, the scale factor 3, so let's multiply that by 3, this one by 3. I get 9 and 6. So going to the right, I want to walk 9 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 to the right and 3 up. 1, 2, 3. So that's where 1, 2, 3, 4, 5, 6, 7. Now, please, I'm gonna go back a little bit. Point B should be 9 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 6 up. 1, 2, 3, 4, 5, 6. Okay, there you go. I messed up. This is point B prime. Point C. Well, how do I go from the center, which is O, to C? If I were to walk there, you would tell me, go 1, 2, 3, 4, go 4 to the right, 1, 2, 3, go 4 to the right, and then go 1 up. Well, scale factor 3 means I multiplied the 4 times 3, which gives me 12, and the 1 times 3, which gives me 3. So, going to the right, I'm going to go 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's point C, but I have to go 3 up. So 12 to the right and 3 up. 1, 2, 3. Let me erase this. And there's my C prime. So let's connect the dots and see if I get the same shape. Do I get the same shape? Yes, I do. Yes, I do. Um, what are the coordinates of triangle ABC? Well, let's see. Point A prime, where's A prime? A prime is 1 to the right, and 1, 2, 3, 4, 5, 6, 7, 7 up. B prime is 1, 2, 3, 4, 4 to the right, and then 1, 2, 3, 4, 5, 6, 7, 7 up. That makes sense. And then C prime is 5, 6, 7, 7 up, and 7 to the right, and 4 up. So that's C prime. So those are the coordinates. Okay, but notice that we didn't multiply the points A, B, and C by the scale factor because we can't do that. The center of dilation is not 0, 0. So we actually had to figure out the horizontal and vertical distances from the center of dilation to the point, and then multiply those distances by the scale factor. Here are the pre-image and pre-image points that describe the transformation. So you can go here. Let's see if I can use this. 0 and 4. 1, 2, 3, 4. Good. 0 and 4. 1, 2, 3, 4. So let's call this A. Let's call this B. Let's call this C. B would be 1, negative 1 and 3. Negative 1 and 3 up. So that was A. This is B. And C is, what is that? 5? 5 and 6. 1, 2, 5, and negative 6. So it's all the way down here. 1, 2, 3, 4, 5, 6. So somewhere over here, out of the graph. That's okay. So this is what we have. And then they dilated it. And now we have 0 and 12. So 0, and this would be up here somewhere. Again, that would have been A prime. So from the point A, so let's compare the center to point A is 4 units. So this guy right here is 4 units. And now from here, from the center to point A prime is how many units? This is 12 units. So what's the scale factor? How did the 4 become a 12? Well, obviously, times 3. Okay. And you would have done the same thing with B and C, which I'm not going to do. Oh, I can. So we found point A primes all the way at the top. Now, I take that back, take that back, because, all right, so let me start the problem again. Well, not from scratch. This was the original triangle, right? I plotted it, draw the triangle ABC and its image on the coordinate plane. So first I drew the triangle. Now, what I forgot to do, ignore, was here is your center of dilation. Negative 5. No, so I'm going to write D for dilation. They want us to use a scale factor of 3, so you have got to be kidding. Everything was good, ladies and gentlemen. I was actually I'm going back to this. No. So go back to this, right? We're in the right track. Good. So far it's good. And then they're asking us what happens. No, that's not part of the problem. So I'm actually answering the problem. So now a prime is 0 and 12, so which is somewhere over here. And b prime is negative 3, 1, 2, 3, and positive 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So over here. Here's b prime. And what are you noticing? 4 to 12 is times 3. Negative 1 to 3 is times 3. How did the 3 become a 9? Times 3. How did the 5 become a 15? Times 3. How did the negative 6 become negative 18? Times 3. So what was the scale factor here? 3. Sorry, I got confused with the previous question. JKL is a right angle triangle. So if it's a right angle triangle, one of the angles is 90 degrees. And one of the other angles is 28 degrees. Can you find the measure of two other angles? Well, 28 is that one. This is 90. Can we figure out what this is right here? Well, it would be 90 plus 28, which is 118. And what do we do with that? We subtract that from 180 because the sum of the angles in a triangle is equal to 180. 10 minus 8 is 2. 7 minus 1 is 6. So this guy here, this triangle, is 62 degrees. Obtuse triangle. Triangle that looks like this. This angle right here is greater than 90 degrees. So this is 72. Remember, this obtuse angle, one of the angles has to be greater than 90. So let me pick a random number. I'm going to pick 92. So 72 plus 92 is going to give us 164. If I subtract 180 minus 164, it's going to give me 16. So if you tell me that one of the angles is 72 and that the triangle is obtuse, a possible combination could be 72, 92. This angle here could be 16. No, not 16. 16. 16 is correct. This angle could be 16. All right, sorry about the confusion on the previous